Hello friends, we're going to talk about sorting this week. Sorting is an operation we're all familiar with. We sort our money by denomination, we sort our books by author, we do all kinds of sorting just naturally. And so we're going to build upon what we learned about arrays last week, and we're going to use those arrays as the container in which we sort data. Now, sorting can be a little bit scary. When you look at some of the algorithms that you'll do down the road, say in CS372, you'll find that it can be much more complicated than what we're going to experience this week. We're going to look at a couple of fundamental sorts in this video, and they both end up with the same result. That is a list of data that is in a proper order, whether it is from lowest to highest or highest to lowest, whatever the choice is. When we go about sorting, the thing that simplifies this operation is that there are only two components to almost every sort. And those two components are the compare and the swap. The first operation is comparing one data value against another. So we begin with the data value A, and we compare it against data value X. And we ask which is larger, which is smaller. If one is larger or smaller than the other, depending on the direction that we're going, then we use the second operation, which is to swap. We take this value, we put it in this location, and take that value and move it to this location. Every sort is built upon that idea. It's just a matter of the order in which we process those commands, or the way in which we approach the data in an array. When we're working with data in an array, we want to keep in mind that the data is in place, and so as we compare it, we're comparing one value in one subscript to another value at another subscript address. And if we're going to swap those, we need to remember that we can't just simply go A equals B, B equals C. We have to copy it out to a third location in order to facilitate the swap. So we're going to look at, in this video, a couple of different types of sorts. We're going to look first at the bubble sort, which is kind of a fundamental sort algorithm. This algorithm is really easy to implement, but it can be terribly inefficient. And what it does is basically take two adjacent values, say subscript 0 and subscript 1, compares them, and if necessary, swaps those values. And then it moves to subscript 1 and subscript 2, and if necessary, swaps those values. The end result of the first iteration going through the loop is that the highest or the lowest value will be in its proper place. And then it repeats again. It goes through until all the values are sorted. The other type of sort, or the type that you will use for your assignment this week, is the selection sort. Selection sort does the same thing. It compares one value against another value, but it goes about it in a little bit different way. Let's say we're beginning with the very first value in subscript 0, and we want to go from lowest to highest. So what I'm going to do is take the value that is at subscript 0, and I am going to compare it against every other subscript. Now, if one of those other subscripts is less than what is currently at location 0, I'll swap that in there. And then that becomes my new value to compare against. So, in essence, the first value that I encounter that is lower than subscript 0, I'm going to swap it in. That becomes the lowest value now. So I compare that against the rest of the values. At the end of the first iteration, just like the bubble sort, that item is in its correct location. That is the lowest or the highest value, depending on the way we go. So we ignore that, and in the selection sort, we move up one subscript. So we're going to compare subscript 1 against the rest of the values in the list. Make sure that's the second lowest or second highest value. Move to subscript 2, and so on, and repeat that until all the items are located. It's really not very complicated. You'll have code in the content section that you can work from. Just remember the two operations. Compare. It doesn't matter if you're comparing characters or strings or integers or doubles. It doesn't matter. Is this greater than that? Is this less than that? If so, depending on the direction that you want to go in your sort, then perform the swap. Now the swap is a three-step process. We take one of the subscripts and we copy that out to a temporary variable. Step 2, we swap the value from one subscript to another. And step 3 is we copy that temporary variable back into another subscript location. Not complicated, very straightforward, easy to understand. So what we'll do is we will look at these operations. We will walk through the sort looking at the movement of different values within the list, and then we'll have a look at some code. And then you should be ready to go to write your program this week. Okay, so here we have an array with 6 characters in it, and we're going to sort these characters using the bubble sort. Remember that the bubble sort looks at adjacent elements in the array, compares them, and then if necessary, swaps them. So if we look at this, the first 2 elements in the array, we have a D and an E. Now we're going to sort this in ascending order, so we're looking for the lowest value. And in this case, the D and the E are in their proper location, so we wouldn't do any swap. When we compare the E and the S, we see that the E is less than S, and so it would stay in its location as well. So this is an iteration, this is an iteration, this is an iteration. Now we've landed here. And so we're going to look at the S and the I. Is S less than I? In this case, it's going to say the answer would be no. And so the operation would be a swap. We would copy the S to a temporary location, copy the I into its proper location, and then copy the S back from its temporary location. And now we're looking at the S and the G. And so we repeat that operation. Is S less than G? The answer is no, so G is a lower value. And so we take the S and we put it in a temporary location. We copy the G into its location, and then we copy the S back out of its temporary location. The subscript pointer moves to here, and we compare the S and the N. And S is not less than N, so once again, S swaps out, the N copies from one location to the other, and the S copies into its final location. And so you can see now that we have gone through one complete loop, or one outer iteration, and now the pointer, or the subscript pointer, is going to move back to the beginning of the list. And it is going to compare D and E, nothing needs to be swapped. E and I, nothing needs to be swapped. Now I and G need to be swapped. So the I comes out to a temporary location. The G gets copied over here. The I gets copied from its temporary location back into the list. And then we compare I and N. No swap. N and S, no swap. End of the list. We come back. So now you've noticed that with each iteration, the lowest, the next lowest, the next lowest are all in their correct location. And in this case, because there are so few elements, we run into one of the greatest inefficiencies of the bubble sort, and that is it will keep going for another 4 iterations, even though the list is already sorted. So the bubble sort, real easy. We compare adjacent elements and swap them. The selection sort takes a little bit different approach to sorting. And what it is going to do is fix one pointer at a subscript location. In this case, it's going to be the 0 location where the G is located. And then it's going to search the rest of the list to find out if there's anything lower than the G. So what it will do is start with the second location. And it's going to say, is G less than I? In this case, it is. And so this pointer will stay fixed. The green pointer, the yellow pointer is going to move. Is G less than N? Yes. No swap. Is G less than E? Well, no. E is less than G, so we require a swap. So the G gets copied out to a temporary location. The E is swapped into the 0 subscript, and the G is placed out here in the list where the E was. Now the pointer moves forward. Is D less than E? In fact, it is. So E comes out to a temporary location. The D gets swapped down to the 0 subscript, and the E is copied back into the list. And this pointer moves over to the S. Is S less than D? No, it is not. Now, the selection sort knows a fact at this point. It knows that at the 0 subscript, the lowest value in the list is in its correct place. So the pointer for the lowest value moves to the 1 subscript, to the first subscript where the I is. And then this subscript moves back, and it starts the process again. Is I less than N? Yes, it is. Is I less than G? No, it is not. So the I comes out to a temporary location. The G gets swapped over there. The I gets copied back in. Is G less than E? No. And so G comes out to a temporary location. E gets copied in, and G gets copied back into the list from the temporary location. Is S less than E? No, it is not. Okay, so after 2 iterations, 2 of the elements of the list are already in their correct location. So by moving forward now, you see that the number of items that we have to search through is growing smaller and smaller, and the number of items that are already sorted is growing larger and larger. So we'll walk through this just once more. So now we're sitting at the subscript 2 where the N is located, and we're going to say, is N, well, let's move our pointer back, is N less than I? Well, no, and so we're going to swap the N out, copy the I over, put the N back in that location, move the pointer. Is I less than G? It is not. Copy it out to a temporary location, put the G in that location, swap the I back in. Is G less than N? Is G less than S? Yes, it is. Okay, and so after 3 iterations, we've got it in the correct location. So we move to N. We move this pointer back. Is N less than I? No, it is not. So we're going to move N to a temporary location, put I in its correct location, put N in its location. Is I less than S? Yes. All right. Now we're coming towards the end of the list, and so we're only going to have to compare a couple of items. And now all we do is say, is N less than S? Yes, it is. It's in its correct location, and we have a sorted list. So just like the bubble sort, the selection sort uses the 2 fundamental operations. It compares one element against the other, and if necessary, if it's less than or greater than, depending on the direction you're sorting the list, it swaps those items out. The swap is a 3-step process. Copy one value out to a temporary location, copy the 2 subscripts, and then copy the temporary location back into the list at the old subscript value. So it's really very simple. All the sort algorithms are built upon this idea. Well, thanks for watching. I hope you found that helpful. As always, if you have questions, you can contact me via email or leave me a message in the Student Questions Forum. Good luck with your program this week, and I look forward to seeing them.